All right, let's hopefully we'll finish up this lesson. So we did the undefined terms. Now we're going to do the defined terms. These are actual definitions, okay, that we're going to use. Now we're going to use some of those undefined terms in our words, okay? So for instance, the first one is this. So write this one down. So this is our first definition. They're called collinear points. Collinear points. So we kind of know what a point is, but what in the world does it mean to be collinear? Yeah, I'll write it down. Might as well. We got time, right? I guess. When do we get out of here? Geometry 1. Does that say 110? Yeah, 110. Oh, yeah, I got plenty of time. We can write these down. I mean, it's in the book, but let's write them down just so they're in our notes. It says points that lie on the same line. Let's see. Yeah, points that lie on the same line. So let's write that down. So points that lie on the same line. All right, so let's draw a little picture so that we can see what that looks like. So here's a line. Well, technically it's not a line yet, is it? Until I put little arrows. What do the arrows indicate? We learned that yesterday. Keeps on going forever and ever, infinitely. Right, that's a good word to use, okay? So if I had a point right here, we'll call it point A. Point right here, I'll call it point B. And a point way over here, point C. What's true about all three of those points? They're all on the same line, that's right. So we say they lie, right, on the same line. So they're on the same line, right? So there's one line, we'll call it line L, right? Or we could call it what? Line AB. Well, we wouldn't use 3. We only use 2. So it doesn't matter which 2 you use. So give me a couple. AB, line AB, line AC, line BC, and then you can go backwards, right? You could go line BA or BA, CB, CA, right? You could use a bunch of different names. Or you could just call it line L, all right? Everybody with me on that? So you could have 50 points labeled, well, 50. We only got 26 letters in the alphabet, but let's say we use some Greek letters. 50 points on here, okay, but we're only going to use 2 points to name it on that line. And okay, those 2 points have to be on the line. So we call these. So A, B, and C would be what kind of points? Collinear, okay? So it's got 2 L's, collinear, all right? Now, what if I'm not going to write a definition down for this, but what if I asked you what non-collinear points are? Take a wild guess. That's right. They're points that don't lie on the same line. Now, if you just had 2 points, can you have 2 points that don't lie on the same line? You could always make a line between 2 points. Okay, so if I had just 2 random points, one here and one here, are they collinear?
They can be.
Yeah, they can be, absolutely. Okay, and oops, kind of off a little bit there. Let me twist it. I think I can. There we go. Is that better? Like that? I should have just redrawn it. There we go. It's good. All right, forget the arrows right now. You know they're supposed to be there, right? I'm just kind of lazy. I don't want to draw the arrows. So those would be collinear, wouldn't they? But what if I had like a third point right there? Tell me something about all 3 of these points. Do all 3 lie on the same line? No. So we would call them what? Non-collinear. Very good. All right. So it's all definitions. These are all definitions. And there we go. So let's talk about this. Now I wrote in my notes, go to the digital image. So that means I think I took a picture when I took these notes a couple years ago. Took a picture in the book, but I forgot to put them on my computer. So you can look at the book, and there are some images here that probably look a little bit better than what I'm going to draw. So you can kind of look at those on your own in the book. Is that all right? All right, let's do another one. Call it 2. And let's call this concurrent. Not points, though. They're called concurrent lines. All right, what in the world is a concurrent line? It's the definition is that they are lines. It could be two or more lines, all right? It's not just two, but it could be two or more lines whose intersection is a single point. Or you could just say that they intersect each other. That automatically means that they're going to intersect at one point, but we're going to write it like this. Okay, so lines whose intersection is a single point. So let's draw a couple lines. All right, there's a line right there. Again, I'm a little lazy to put the arrows on there. You okay with that? But you know those lines are supposed to keep going, right? All right. And let's say like this. Those are two different lines. So we'll call it line L and line M, just to make it kind of easy. Everybody okay with that? Now, what do? They cross each other. So what do you think that means in my little definition right here? It's the what of the lines? The intersection. That's right. When they cross each other, when they touch each other like this, that means that they intersect each other. Okay? So that we didn't really write that definition down, but you kind of know what the word intersect means, right? Right? You go to a road, go to the intersection. What does that mean? It means that's where they cross each other. Okay? That's intersection. And they intersect at a single point. So boom, we'll call that point A. So point A is the intersection of what? Line L and line M. That's right. Okay? And so that means line L and line M would be considered what? Concurrent lines. Pretty easy, right? Yeah. Again, we're just learning the language, okay? Geometry has its own language. We're just learning some vocabulary in this language that we're trying to learn right here. Yes? You could have a bunch of points on the lines if you want, but this is the only one that I picked out because that's where it intersects. You could also, remember I said you could have two or more, so it's not just two. You could have a whole bunch, couldn't you? All right, let's say right there. So let's say that that's line P. All right, so all three of those lines are what? Concurrent lines. Why? Because they intersect at a single point. Okay? Everybody got it? All right. So what about this? What if I took that line and did that? Are all three of those lines concurrent? No, because they don't all three intersect at one single point. Right? Now, two of them do here. These two do right here. These two intersect right there. Okay, but it doesn't mean that all three of them are concurrent. Okay, only that all would be concurrent. Got it? Okay, good.
What would the other one be
if it was like it was before? Yeah. Whoops. Like that?
Yeah.
Then we would say, if this was still point or line P, whoops, there it goes. Okay, so if that's still line P, we would just say, what, L and P are concurrent at this point. Now, I didn't label the point, but we could put it maybe a B there, right? So you could say line L and line P are concurrent at point B. We could say that line M and line P are concurrent right here at, let's just call it C, at point C, all right? Okay, all right, good, enough of that. All right, let's do a little example. This is kind of what you might see on the homework and on a quiz or a test or something. It may not be like exactly the same letters and stuff, but I do remember this being on a quiz and a test. Something very similar to this. Yeah, this is an example just to kind of show you. I mean, we kind of did an example already, but this is an example that just shows you a little bit more about concurrent lines. Yeah, always write it down. Anything I write up here. So that's line K. That's a lowercase k. This is line L. This is line M. And this is line N. All right, we got some points. So this, now even if they don't put the dot there, if I put a capital R, what do you think that?
But it's a point.
Yeah, it means this point right here, even though we don't put the dot. Everybody okay with that? All right, so because just a capital letter sitting around by itself means in geometry, what does it mean? It means it's a point, right? So what's the closest point to that R? It's right there, okay? You'll see that a lot, so you just have to make sure. All right, so this point of intersection right here is point T. This is S. And now this isn't, nothing intersects where that point is right there, but I'm going to call it V. And I think that's it, okay? So it says name 3 collinear points. So like number 1, 3 collinear points. That means what? Collinear. They all lie on the same line. So do you see 3 points that all lie on the same line?
Yeah.
What are they?
T, V, and L.
T, V, and S. Very good. It's this line L. Do you see line L? In fact, that's the only line that has 3 points on it. Would you agree? Line K only has 2 points on it. Line M's only got 2. Line N only has 1, right? So line L is the only one with 3 points. So what we would say, we would just say T, V, and S, and just put commas in between. You don't have to say point, because if you put a capital letter and there's nothing else with it, that automatically means it's a what? It's a point. That's right. Everybody good? All right, so that's 3 collinear points. If you want to write that down, 3 collinear points, just so you know what I just did right there, that might be helpful. I'm just not writing it. Okay, let's name 3 non-collinear points. Now, you might have a lot of different answers, okay? Oh, by the way, does it have to be in this order, T, V, and S? No, it's just, as long as you have T, V, and S in there, it doesn't matter what order. What about 3 non-collinear points? So they're not collinear. You got to leave. Volleyball? Okay. Zanaya, right? R, T, and V. Good. All right, so that's one potential answer. Is that the only answer? No, it's not. Okay, you could have a lot of different answers to this. You could say what? R what? RVS. Yep, RVS. Say it again. S what? SRT. Yeah, there's a bunch of them, aren't there? Okay, a lot of them. So as long as they don't all 3 lie on the same point. Now, 2 of them can lie on the same line. Okay, but remember, all 3 of them cannot be. So really, any combination of any of these letters except for T, V, and S. Okay? So that's non-collinear points. This is collinear. This is non-collinear. I think I might have told you this yesterday, but after you do a homework and I'm sitting there and I'm reading off answers, if I say RTV and you don't have RTV on there, you've got RTS. You need to be able to look at it and say, yeah, that's the same thing as what he said, because there's no way I can just read through all the possibilities. It'd just take forever to get through, a homework lesson. So you will see a lot. Like in algebra, basically if the teacher read you an answer, you had to have exactly that answer, right? And that was the only choice. But in geometry, sometimes you have a lot of different choices. All right. Number 3, 3 concurrent lines. 3 concurrent lines. So look at this situation. What does that mean to be concurrent? The 3 lines must do what?
Intersect.
They must intersect at one point. Okay. Sanaya?
Line K.
Line K.
And line L and line N. All intersect at point.
Did you say M or N?
N.
N? Okay. And what else? So K and L, right. Okay. And again, it doesn't matter what order you put it in. Very good. All right. Did you see line K? It goes right here, but it intersects in 2 places, right? Up here and here. Line N intersects here, which also intersects K, and line L. So all 3 of those lines intersect right there at that point. That means they're what? What's the word? Concurrent, right. They're concurrent lines. Make sense? Yeah, that's good. All right, it's not too hard, is it? Nah. All right. Let's do a few more. Again, I have a little note here that says use a digital image, right? So you probably have pictures in the book. I'll try to draw my own picture. It might look a little different than what the books, but it's probably close to the same. These are a little bit different because this is talking about things are on a plane, right? So I put a 1 here. The first 2 are points and lines, and now we're doing definitions that deal with a plane. So the first one, use that word co again. The word co means with, right? So with or on sometimes. So that's kind of what that means. So coplanar. Now this is how they spell planar. P-L-A-N-A-R. So coplanar points. Now we've already talked about collinear points, meaning they all lie on the same line, right? Points that lie in the same line. What do you think this means? Coplanar points. You got it. It's exactly what it is. I'll let you write that down because I'm going to draw a picture here, and I just want to be able to. So they're points that lie in the same plane. All right. So write that down. I'm not going to because I'm drawing this thing. Points that lie on the same plane. So let's slant this a little bit. So that kind of looks like our plane from yesterday, doesn't it? So how do we label a plane? Do you remember that? Put a lowercase letter, right. What do you want to call it? S? All right, well, that could be uppercase or lowercase. But anyway, I mean, the S's kind of look the same, don't they? Whether it's upper or lower. Anyway, there you go. That's a lowercase s. So it's plane S. And we want to put, let's put 3 points. Because really, any 2 points could lie in the same plane. But when you have 3 points, well, actually, any 3 points, you could have a plane that goes through any 3 points. But let's just do this. Put a point here, put a point here, put a point here. Now, remember what I said about a plane? Does a plane stop? Does it have edges like it looks like in this picture? No, it keeps on going forever. I can't physically draw anything that goes on forever and ever. So we just have to understand that even though it does look like it has edges right there, it does keep going forever, right? But these points are on the plane. So we'll call it A, B, and C. So what would we call these? If all 3 of these points were on the plane, we would say that these points are what? Coplanar points. Very good. Everybody with me? Good. And what about non-coplanar? This is like a subset. I'll still keep it under number 1. That's right. They don't lie on the same plane. So non-coplanar. So watch this. What if I stuck a point right there? This means that it's not on this plane. For instance, look at this screen right here. You have to think 3-dimensional, right? It's only a 2-dimensional screen, agreed? But think of it coming out here. So think of that point D coming way out here like this. So does point D lie on the same plane as those other points that are on this screen? No, they don't. So that's how you have to think of point D. Even though it's on the same flat surface, this screen, you just have to use your imagination when you draw these in 2-dimensional spaces, okay? So point D is not on the plane, agreed? All right, so what's true about all 4 of these points? Now, 3 of them are in the same plane, but what about the 4th one? It's not on the same plane, so we would consider all 4 of those points what? Non-coplanar, okay? Everybody got that? Or you could just say B, C, and D. What's true about B, C, and D? They're non-coplanar. Okay, you got it? Okay, let's talk about coplanar lines. I'm going to use the same picture so I don't have to redraw it again. Let's get rid of these, and it shouldn't take much thought to talk about coplanar lines. Tell you what, let's do this in a different color. Mix it up a little bit. So, what if you had a line right there and a line? Yeah, let's put 2 different colors. And what if you had a line right here? Okay. Again, pretend there's arrows on. Again, I'm being lazy, but to really be a line, you got to have arrows on both ends. But what do you think might be true about both of these lines, the yellow one and the blue one? They all lie in the same plane. Exactly right. Okay. So those 2, the yellow and the blue, call it Y and B, right? They all lie on the same plane. Here's a situation that you're going to see every once in a while. What if I did this? We'll keep those there for right now. What if I said, let's do it right here. Oops, I thought I turned it to red. Let's turn it to red. There we go. Okay, and then what I'm going to do, this is going to kind of look weird, but I'm going to explain it to you. Now I'm just going to freehand the rest of this. I put dotted lines. What's going on there? Oh, did you have one like that? Well, good. All right, I'm trying to make that so it's the same angle as that one up there. It might not be perfect, but you get the idea, okay? So what's going on here? Let's put some arrows on there. So this is a line, but is this line on the plane or in the plane? When I say on the plane or in the plane, that basically means the same thing, okay? So you have a line, okay, I'll just use this pen. See this screen? That's my plane. This line right here, boom, that's on the plane or in the plane. You could say it either way. But what's that red one doing? It's going what? Through it, right. It's going through it, exactly right. So the solid part, do you see the solid part at the top right there? Right there? The solid part, like, again, look at this plane. It's this part, but then it goes through the other end, right? Actually, let's use a piece of paper instead. Yes. I got some cardstock. It's a little stiffer, okay? So watch. So here's the top of the red part, right? This is the dotted line that you don't see, right? There's a part of that pen you don't see. But then it starts coming out, and then you start seeing it again, okay? So that's what's going on. You see that? So this part, so this is not on the plane or in the plane. What's it doing? It's going what? Through it. Or what's a better word where it hits it and it connects it? We've already used it today. What word when it touches it, when it meets it? Intersects. Very good. Okay? So this line intersects this plane at that particular point, right? This pen doesn't write because it's for my graphics tablet, but right here, there's a point. Okay? The line and the plane only intersect at one point. You got it? So how does a line and a plane intersect each other? They intersect at a point, right? So that point that I drew right there, do you see this? We'll call it P for point. Is that right? And we'll call this L for line. Sometimes I'm not very imaginative. I just use the same letters over and over again. All right, so this line, L, intersects what? Plane S at point P. Okay? And I think you might have a problem where they describe it to you in words and you have to draw it. Is that right? Yeah. And that's what you would do. That's how you would draw it. Okay? The blue one and the yellow one lie on the plane. Line L intersects the plane. So all these words are really important. Okay? It's not like we're just going to learn it one time and then forget about it. Really, the rest of the year, a lot of the stuff that we're talking about is going to come back again. All right? So we're going to be using these things a lot, really, throughout the whole year.
So wait, the yellow and blue line,
Now, they may intersect. Is that what you were going to say? Look, like if I extended this like this, right, and I extended it like this,
so those could technically be intersected.
they intersect each other. That's true. They absolutely do intersect each other. And they intersect each other at that one point right there. But they're still on the plane.
So would they be concurrent?
They would be concurrent lines. Yes. Okay. Very good. Good questions. I think I'm going to like this class. All right. Let's see what else we got. Oh, okay. This is a funny word. Go back to whites.
Oh, right.
All right. How should I draw this? I'll tell you what. Let me copy this again. It's a little too messy, so I'm gonna draw it again. Which one? The blue one and the yellow one would be coplanar lines, but the red one is not coplanar because it has to lie in that particular plane, and line L does not lie in this particular plane. But the yellow one and the blue one are coplanar, yes. Okay? All right, let's do another one. Watch this. So, what if I had, we'll color it again. Go this nice pink, I like that color.
Is this still a non?
This is a different word. Just drawing it right now. Okay, so let's say you have a line right there, that pink one. And let's say you had another line. And this should look familiar because we did this already. And then dot, 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 dot. and then like that. Okay? All right, everybody see this? Okay. So look at the pink one. What's that? Is that yellow? It looks yellow, doesn't it? All right, so the pink one and the yellow one. Are they coplanar? No. Okay. Do they intersect each other? It looks like if you extended this one, it would. But really, what's happening with it? This one's not lying on that plane, though. Remember, this one's like this. Okay? Is that pink one going to hit the yellow one? It's not going to, is it? Because it comes out of the plane like this. So neither one of those are coplanar. So when you have that situation, when you have lines that don't intersect each other but are not in the same plane, okay, we say that they are skew lines. That's the funny word I said we're going to say. They are skew. We're rarely going to talk about skew lines, but it's just good to know. All right? So skew lines. So they're lines that are not coplanar. All right? They are non-coplanar lines. Because the pink one is in that plane. The yellow one is not in that plane. So those two lines would be considered coplanar. Yes? All right. Let's do another one. Everybody got that?
Yeah.
Oh my, I didn't want to. Just, they're non-coplanar lines. There we go. All right, everybody's paying attention, right? We're not going to go off onto tangents, especially after I just said I'm going to like this class, right? You wouldn't do that to me, would you? What? That's my point. You weren't listening. All right, let's do another one. Watch this. I'm going to draw a line right here. Now, with this computer program, it's kind of nice because I can make one exactly the same. Watch. Copy. You know how to copy on a computer? What's the keyboard shortcut? Control, right? You don't have to say CTRL. All right. Control C. Very good. How do you paste? V. Right. My other class yesterday, the kid asked, how do you copy and paste? And somebody, Control C. He says, how do you paste? Somebody said Control P. I'm like, no, it's not Control P. What's Control P almost always? Anybody know? No? Control P. It's print. It's print. All right? Control V, it pastes it. So look, these two lines are exactly the same length and they're the same angle and everything, okay? Again, it should have arrows on the ends, but I'm just not going to do that. Now, will these lines, first of all, are they coplanar?
No. Yes, they're on one thing.
They're all on the same plane. Yeah, they're on the same plane. They don't have the dotted line, right? They're not going through like this. They're both. Like if I had two pens right here, boom, boom, right there. Okay, and they're slanting the same exact way. No, you still with me? Fight it, man. Fight it. You're good. I can see. You're trying. All right. So they are on the same plane. And will they ever intersect each other?
No.
Because I copied and pasted, right? So I slanted them the same exact way. They're going to keep going forever and ever and ever and ever and never what? Never touch, intersect. Okay? So we have a name for that. That's it. And this is a word you probably heard before. But these are parallel lines. You've heard that before, haven't you? Parallel? Yeah. Just what did anybody watch the Olympics? The men do this thing with the two bars. What do we call those? What do they call those bars? They call them. No, they got just two straight bars. Come on, I'm trying to hint at something. They're right. They're called parallel bars. Okay, because they're right next to each other. One's not higher, right? The girls do the uneven bars, right? But the guys do the parallel bars, right? So they're never going to touch each other, right? All right. Now the uneven bars will never touch each other, but they're in different planes, aren't they? All right. So anyway, there you go. So that's parallel lines. So they're coplanar lines. They lie in the same plane. You can write it down if you want. They're coplanar lines that do not intersect. That's the definition. They're coplanar lines that do not intersect. And we have a little symbol for that. We're finally getting into symbols. So let's call this line L and line M. I don't know why. I just like using those letters. The book uses those letters a lot too. So here's how we would say it. if I wanted to show you that those two lines are parallel to each other, this is what I would do. Everybody watch. Line L is parallel to line M, but we need a little symbol for parallel, and we got one. And they're just straight up and down lines like this. Okay? So that little symbol, that's a symbol, that means parallel. Okay?
Like an example, please?
Probably, yeah. I don't have the book in front of me. I just took notes on it, but yeah, that's probably what it says. We got one more to do, and then we'll be done. Okay? Let me see. I tell you what, I'm not going to draw this. Is there a box? Can you grab me that cardboard box right there real quick? Yeah, yeah, real quick, because I'm running out of time. I only got like 2 minutes left. Any cardboard box? Oh, I got one right here. Underneath the table. See the cardboard box? Yeah, they're empty. There you go. Perfect. Okay, thank you. All right, here we go. Everybody look up here. Now, if you're watching this on YouTube, you won't be able to see this, but that's all right. It's too hard for me to draw this on the screen, so I'm just going to show you. Parallel planes. You might want to write it down. All right, so parallel. And there's a picture in the book. Whoops. Yeah, if I could draw a cube, and I probably could, it would just take me too long. Good. All right, so parallel planes. They're planes that are not going to do what? Intersect. Okay, so take a look. See the front of this box? Okay. Which plane would be parallel to this front? Give me a word. Front, back. Very good, okay? So you got the front and you got the back right here, okay? So those planes, you see where my hands are right there? Those planes are parallel planes. There's other parallel planes, aren't there? Okay, like this, where my hands are. Okay, those two sides, those two ends, whatever you're going to call it, okay? Top and bottom, right, left and right, however you move the box. So these would be parallel planes. What would happen with this plane right here and this plane right here? They intersect. How do they intersect? What do they make? What do they form when they intersect each other? Another line. That's right. Because remember, planes don't have edges, do they? This plane keeps on going forever, this way, that way. So does this plane. And what are they going to do? They're going to intersect at this line right here. So that line would keep on going forever and ever. Are there other lines of intersection? Sure. The top and this side intersect at this line right here, and on, right? I could keep doing this all day, but you get the idea. Make sense? So that's parallel planes. Yeah, that's pretty much it. So I did give you the homework yesterday. I'm going to write it down one more time. So this is official today. So here's your official homework. It's section 1, 2. It's pages 8 and 9. And it's 1 through 18. Yep. If you did it all yesterday, then you don't have anything to do today. But there you go. That's it. Section 1, 2, pages 8 and 9, numbers 1 through 18. All right, that's it.